Hello everyone, welcome back to my channel. Today we are going to learn the remaining part of refraction of light, okay, class 9th. So in this video we are going to learn about Snell's law, total internal reflection and its activities, application of total internal reflection and its daily life relation to daily life, okay, and refraction to a glass eye. Okay, let us start our first topic. Before going to the topic, we'll learn a certain terms which we have already learned. We'll revise it, okay. What is an incident ray? Incident ray, the ray of light that is incident on the surface. You can see in the picture that the light is intersecting on a particular surface. That is nothing but your incident ray. Next is refracted ray. Ray is nothing but the ray of light that is refracted at a particular surface. From a particular surface, if it is touching and it is more bending into that is nothing but refracted ray. Okay. Next is normal, the perpendicular to the interface, the straight line as you can see in the picture, that is nothing but your normal. Next is angle of incidence, the angle that the incident ray makes with the normal, that is angle of incidence. The angle that the refracted ray makes with the normal, that is nothing but angle of refraction. The last is nothing but refractive index, the ratio of the velocity of light in air to the velocity in medium is nothing but refractive index. Next is Snell's law. Snell's law is a formula which is used to describe the relationship between the angle of incidence and refraction. Okay, whenever we are referring to light or any other waves passing through it, so this is nothing but the formula. Okay, what's the formula? The ratio of the sine of the angle of incidence to the sine of the angle of refraction. Okay, see the word refraction. Okay, which is a constant for the light of a given color and for the given pair of media. So our formula for Snell's law is sin I by sin R is equals to N2 by N1. N2 by N1 is the ratio of refractive indexes and V1 by V2 is the ratio of the speeds. Next is application of Snell's law. So Snell's law has many real life application in many optical apparatus such as eyeglasses, contact lenses and cameras. There is an instrument called as the refractometer that uses Snell's law to calculate the refractive index of liquid. So in liquid it is applicable. Snell's law, it is also a basis of optical technology, the technology which you are using because of the laws of reflections due to fiber optics, where we are using the cables in telecommunications and data transmission. So here everywhere Snell's law is used. Next is total internal reflection. So the phenomena which occurs when the light ray travels from more optically denser medium to less optically denser medium. So that is nothing but your total internal reflection. So we are having many applications to total internal reflection. Okay, suppose if you are standing on a particular, let us do an activity. Okay. Consider the following situation. A ray of light is passing from a medium of water, as you can see in the picture, to that of air. So the light ray will be refracted at the junction separating the two media. Okay. Since it passing from a medium of higher refractive index, okay, it is passing from water. It is passing from water to air, right? Yes, so it is having higher refractive index. Okay, to that of a lower refractive index it is passing. So that's why the ray of light is bending from the normal. Okay. At a particular angle of incident, the incident ray of light is refracted in such a way that it passes along the surface of water. After some time, you can see in the third one, right? Third picture. So this particular angle of incidence is called as a critical angle. Okay, the ray of light at which it is passing along the right direction of water, yes or no? You can see in the second picture, critical angle. So that is nothing but your critical angle. Here the angle of refraction is 90 degrees. When the angle of incidence is greater than the critical angle, if it is greater than the critical angle, the incident ray is reflected back again into the medium, means it is coming again back into the water, as you can see in the third picture. So we call this phenomena as total internal reflection. Okay, let us quickly revise what we have seen just now. The first picture, the incident light is coming from the water. Okay, it is moving into the air, and here you are able to see a proper refractive index. At a particular angle, it is moving along the surface of water. That is nothing but your critical angle. If it is more than critical angle, okay, then what happens? The ray will bend it again into the same medium. Okay, as you can see in the third picture, that is nothing but your total internal reflection. Let us see applications of total internal reflection. The first is diamond. At a 23 degrees of angle, if the incident ray is incident on a particular diamond, so you will able to see total internal reflection. Okay, because of the angles how it is cutted. Okay, the diamond is shaped. Because of that shape, we are able to see the total internal reflection phenomena in diamond. because of that only it will shine. The next is mirage. Mirage is nothing but an optical illusion that is responsible for the appearances of the water layer at short distances in a desert or a road. If you suppose if you are traveling in a desert, you will able to see on a long distance, you are able to see water. You must have seen in movies, right? So that is nothing but your mirage, an optical illusion. Because of the atmospheric refraction it happens. Okay, the third is optical fiber. In optical fibers also we are using the refraction only. Okay, so optical fibers are also used in endoscopy, okay, which is a method, which is a scan of your stomach and all. Okay, it is used in medical purpose. The next is refraction through glass slab. Let us do one activity. Take a glass slab, put it on the table, take a torch. Are you able to see the refraction? Right, the light is bending when it is passing through the glass slab. Yeah, it's looking beautiful, right? And incident beam are parallel. Yes or no? Are you able to see the incident beam is parallel to each other? So whenever you are passing through a glass, refractive index formula is thickness of the slab by thickness of the slab minus vertical